Hi guys, this is Dave Marshall with the RC Air Marshall YouTube channel, and you are watching the Spektrum AR636 programming series. This is part 7, where we'll go over the initial model creation using the Spektrum Programmer software on your PC. All right, to do our initial model creation, we're going to be working in the Spektrum Programmer. When we go to Models over here in the in the left-hand pane, we'll go to Models. And we want to make sure that the model that we want to edit is the one that's highlighted. Now, in this case, I've got, 3 different models here that we could load into this receiver, but the one that we want to work with is the Recomroy Old Crow P51 Safe model. So we've got that selected. Now, if we wanted to choose one of the other ones, we would highlight them and click select, but we're already good. We can see that it is bolded, which means that that is the current selected model that we're going to be working with. So to continue, we're going to go down here to model settings. Now, when we did the overview of the software, we had mentioned that we're going to always set up exponential and dual rate. I always do those in the transmitter, so I do not set those up inside the receiver. Now, when we get to gain and priority, we will be setting those up inside the receiver. Now, basically what this is going to entail is us setting up a gain and priority setting using either absolute or relative values for each of the flight modes that we want to have available on a 3-position switch. Now, this isn't something that should be confused with setting up flight modes inside the transmitter. It's effectively the same as, say, an apprentice, where we have a 3-position switch that allows us to use something like, say, one will have an experience mode, a beginner mode, and an intermediate mode. Right, so it's not the same as flight modes in the transmitter. We can set up any 3-position switch in the transmitter, and the flight modes are actually set up in the receiver. All right, so for the purpose of this video, we are going to set up 3 different flight modes. One of them is going to have the gain turned completely off on all 3 axes. So our roll, pitch, and yaw will have no gain. In our second one, we will have the gain turned up just slightly. We'll turn our gain up to what we want it to be for that particular axis. And for the third flight mode, we will actually mimic the settings of flight mode 2, but flight mode 3 will be set up for safe. So what we will do is we will have flight mode 1 be our 0 gain setting. Flight mode 2 for roll, we will set that up at 40%. And we'll mimic that for flight mode 3. Because we want flight mode 2 and flight mode 3 to have the same gain values. So AS3X works the same. And then we'll set up flight mode 3 as our safe flight mode. And that will be done in a later part of the series. All right, so the other thing that we want to look at here is we've got absolute and relative. And basically what that means is absolute values, when we set up absolute gains, it means that the gain cannot be changed once it's set. The relative values allow us to adjust the gain in flight using a DX9 or better transmitter. So if you don't have a DX9 or better transmitter, the relative gains aren't going to do much for you. So we would set up everything to be absolute for, say, like a DX6 or a DX8. But if we do have a DX9, you could select relative, and we'll explain that in another part of the series, where we'll have a completely different part of the series specifically for relative gains. But for now, for this part of the setup, let's leave them all to absolute. The next thing we want to look at is our stick priority. Now, the stick priority, effectively what that is how much gain is going to be applied based on the position of the stick. Now, this is what kind of differentiates the AR636 from most other gyros out there. And what I want you to pay attention to is the graph. Now, if we look at this graph, and this is in the roll axis, so imagine, you've got your stick dead center, which, we'll have this graph, and it's got, gain over here on the right-hand side and stick position here on the bottom. And this center line represents the stick position. So as the stick, say we move the stick further to the right, what you'll see is the gain, as we move the stick further to the right, the gain starts to drop, and it doesn't drop all the way to 0 until we've got the stick moved 100% to the right. Now what I want you to look at is as we adjust the priority, we're going to modify that curve. So as I move the priority to say 170%, which is where I personally like it to be, what this does is makes it, as we move the stick off center, the gain slopes off dramatically. So the only time that the AS3X gyro is really affecting the flight performance and keeping the plane nice and level for us in high wind situations is when the sticks are dead center. As we move the stick to the right or to the left, you can see that the gain slopes off quite dramatically. And when we're at about 20% of the travel of the stick, we're at 0 gain at that point. So you can see here's stick center. As we move further to the right, the gain slopes down, and at about 20% of movement to the right, we have 0 gain being applied to that particular control surface. And we'll go ahead and set up 170% stick priority in flight mode 2 and flight mode 3. And like I said, what that does is it gives the airplane a more natural feel, right? So when you're in your in flight and you're flying straight and level, the plane's going to be nice and stable because the gain settings are going to be counteracting the effects of wind. And when you start to go into a turn, it's not going to feel unnatural, right? Because as you move the stick to the right or to the left, you're going to have less interaction from your from the gyro, and you're going to be basically flying it by hand. And once you go beyond that 20%, and even as you move, say, into the 10%, we're using a lot less gain, because even at 10% to the right or left, we've dropped the gain by almost half. So the stick priority, to me, is what makes the AR636 just a much better feeling gyro than something like the Hobby Eagle, for example. All right, so let's go ahead and do the same for our other 3 axes. So we set up our 3 flight modes for roll. Let's move on next to pitch. Again, for flight mode 1, we'll have our gain set to 0. For flight mode 2, for pitch, let's do 40% again. And 40% is just, to me, that's a good place to start. And then we can adjust those at the field using the mobile app, which we'll discuss in a later part of the video. And again, I like to set my stick priorities to 170%. And let's move on to yaw. Typically for yaw, I like to use a little more gain. and that's going to be controlling our rudder axis. So we'll go up to 50% for yaw. And again, put the priorities at 170. And there we go, 170. All right, so as we roll through the three different axes for gain and priority, we've got our roll or aileron set to 40% gain with 170% stick priority. We've got pitch set to 40% gain with 170% stick priority. And we've got our yaw set to 50%, and that covers flight mode 2 and flight mode 3. And remember, flight mode 1 is going to be our first position of our switch, which is going to have the gain turned off. So our three positions are going to be position 1 will have no gain, position 2 will be AS3X, and position 3 will actually have safe included. We're not going to mess with mixing for now. We will go ahead and assign a flight mode switch. So for this particular aircraft, it is a 6-channel aircraft, so we can't use the gear because gear will be utilized by the landing gear. Aux 1 will be on our flaps, so we'll go ahead and set up Aux 2 as the channel that's going to receive our switch inputs. So that's what we're talking about there, is which channel on the receiver is going to receive switch input data from the transmitter. So we will set up a switch on the transmitter to transmit to Aux 2, which will alter our flight modes in the AR636. Under aircraft type, we will select normal with a normal tail. And for now, until we get it into the airplane, we don't really know how the surfaces are going to be set up, whether we want them to be reversed or, we're really not going to mess around with the balance of the servos because we are only running one servo on both sides. Usually with a Y connector, the balance is good if you're running multiple servos. Say you've got independent servos on the left and right side ailerons or the left and right side elevators. You can balance those where you've got, throughout the movement of the stick, you've got the same amount of elevator movement. If you're using, 2 servos that aren't the same, that's what that would be used for. But here is where we would go if we wanted to adjust the travel and set up the reversing of the servos. Now, something to keep in mind, and I mentioned it during the overview of the software, and this is extremely important for AR636 receivers, that the receiver orientation and reversal of servos must happen in the receiver. And the reason that's important is because we want the gyro correction to move the servos in the right direction. Now, I have heard some feedback from some other folks who say, like, I can do that with Hobby Eagle. I can reverse my servos on my transmitter and not have a problem. Well, one of the things to keep in mind with something like the Hobby Eagle gyros is they have a little arrow on them. They tell you this, this can only point forward. The pins have to go in one direction. Because we have the ability to basically orient the AR636 any way that we want inside the airframe, that is why it's so important to make sure that we get this right. Because if you're moving to the right and it's trying to correct to the left, or it's trying to correct further to the right, you're going to end up with an airplane that gets crashed and is somersaulting down the runway as soon as you get up off the ground. It's not pretty, and we just need to focus and make sure that we don't reverse any of the servos in the transmitter, that's all done in the receiver. Just trust me on that one. It has to be done that way. All right, and the next thing we're going to look at is port assignments and fail-safes. Now, by default, everything is going to be basically set up the way that we want it. You know, so for standard Spektrum transmitters and Spektrum receivers, our channel 1 is always going to be throttle. Then 2 is going to be our ailerons, which is what we have here. 3 will be our elevator. 4 will be our rudder. So we can see that all of that is set up correctly. And then gear will be on port 5, and aux1 will be on our flaps, or port 6. aux2, aux3, and aux4 are not assigned here. All right, and then over here, we'll see how we want the failsafe to act. Now, the failsafe, there's a couple of different ways that we can set up failsafe within an AR636 receiver. The first one that we see is our preset, right? And what that means is as you are binding an AR636 receiver to a Spektrum radio, you can have the sticks in a specific position as you're binding the radio, and whatever position your sticks are in, that will be the failsafe of the receiver. So that will be the preset the receiver will have in it, and in the event that we have a loss of connectivity between the receiver and the transmitter, it will go into a failsafe mode, and it will do whatever the sticks were doing at the time of the binding of the radio, you know, between the transmitter and the receiver. The next thing is hold, right? So whatever position everything was in at the time of your signal loss, it will hold that position, right? So typically our throttle's at 0, so we leave that preset value at 0 when we bind the radio. All right, the aileron, it has set to hold, elevator hold, rudder hold, but that may not be the best thing. All right, and then our gear is also set to hold and aux1 set to hold. So whatever values they were at the time of signal loss, it will continue that until it regains signal, right? But I don't necessarily like all that. I want my aileron, elevator, and rudder to do, to go into the safe mode and level the plane, right? So what we'll do is we'll select safe for the aileron, elevator, and rudder, and that will level the plane off and cut the throttle to 0. Now, because your gear and your flaps are set to hold, effectively what that's going to do is in the event of a signal loss, it will level off the plane and cut the throttle. And because it's got safe, it will maintain level flight all the way to the ground. The only time that would change is in the event that your safe mode, the attitude adjustment needed to change a little bit, and we needed to give it a little more nose up attitude. But for the most part, this should do very well, and should be able to recover the airplane, or it's going to put the airplane really nice and pretty right into a tree or something like that. But the point is that it will attempt to correct itself. It will attempt to achieve level flight in the event of a brownout or signal loss, and it will should nice and smooth landing somewhere. Maybe not very smooth, but it should be level, and the plane would be somewhat recoverable. Now, in the event of a brownout, that's a little bit of a different scenario where we have a power loss inside the airplane, or a loss of power to the receiver. If we lose power to the receiver, no failsafe is going to work, right? So this is only in the event of a signal loss, right? So again, we've got preset, which holds the values of the sticks at the time of binding. Hold will hold the values at the time of the loss of signal, and safe will attempt to self-level the airplane while bringing the throttle to whatever position you have it in. All right, and that's pretty much all of the different things that we can assign to the AR636 during the flight setup, or during the initial setup. So again, just to kind of recap, we don't set up anything for exponential or dual rate. We're basically only setting up gain and priority, right? So for our roll, pitch, and yaw axis, which are the three tabs up here at the top, we've got our three positions of our switch, which will be flight mode 1, which we have 0 on all three, flight mode 2 at 40% for roll and pitch, and yaw is at 50%, and then flight mode 3 mimics that, and we're going to set up flight mode 3 to be our safe mode using the safe model builder. All right, we don't set up any mixing here for now. The flight mode switch is set up for aux2. The aircraft type is set up to normal with a normal tail. The surface setup is all set up by defaults for now. This will be something that we would change after we get it installed in the airplane and we start correcting for control surface, travel, and things like that. And then our port assignment and failsafe, which we just talked about, where we've got each one of our control surfaces, the ports they're assigned to, as well as our auxiliaries. And then our failsafe assignment, which is over here on the bottom right. So that is pretty much all of the things that we need to do during the initial model setup. So we're going to be moving on to the next part. All right, so that's all there is to the model creation portion. Stay tuned for part 8, where we'll go over how to save your model and export your model files.